In this example, we will make p the subject of the formula. R equals the square root of 4 plus 3p squared over s. I notice I only have one p term on the right-hand side of my equation. In order for me to make p the subject of my formula, I need p on one side of my equation. My preference is the left-hand side. In order for me to get it there, I need to first remove the square root operation being done on the fraction 4 plus 3p squared on s. Well, the opposite operation of a square root is squared. Since I will be squaring the right-hand side of the equation, I must also square the left-hand side. So I get r squared is equal to, and I will be squaring the square root of 3p squared over s squared. I end up with r squared is equal to 4 plus 3p squared over s. On the right-hand side of my equation, I can see that the p term is being divided by s. I need to remove this s term there, so I need to use the opposite operation of division, which is multiplication. R squared times s is equal to 4 plus 3p squared over s times s over 1. On the right-hand side, I have s in my numerator and s in my denominator, so the two of them can divide into each other. I'm left with sr squared is equal to 4 plus 3p squared. I can rewrite this formula as 4 plus 3p squared is equal to sr squared. I now have my p term on the left-hand side of my equation, but I'm not done yet. I need to make p the subject of my formula. So I need to remove this 4 on the left-hand side of the equation. I will use the opposite operation of adding, which is subtracting. So I get 4 plus 3p squared minus 4 is equal to sr squared minus 4. I end up with 3p squared is equal to, because 4 minus 4 is 0, sr squared minus 4. So we have 3p squared is equal to sr squared minus 4. My p term is multiplied by 3. I need to remove this 3, so I need to use the opposite operation of multiplication, which is division. So we get 3p squared divided by 3 is equal to sr squared minus 4 divided by 3. Whatever I do on one side of the equation, I must do on the other side. I have 3 in my numerator, 3 in my denominator. The two of them will divide into each other. So I have p squared is equal to sr squared minus 4 over 3. My p term is squared. And in order for me to make it the subject of the formula, I need to remove the square on my p term. The opposite of squared is square root. So I need to get the square root of p squared, and that is equal to the square root of sr squared minus 4 over 3. I end up with p, because the square root of a squared term is the term, is equal to the square root of sr squared minus 4 on 3. P is now my subject of formula, and it is equal to the square root of sr squared minus 4 on 3. That is my answer. In this example, given the formula below, express t in terms of x and y. 4 over x plus 3 over y is equal to 7 over t. I want to express t in terms of x and y, which means I want t to be my subject of formula. I have t in the denominator on the right-hand side of my equation. So my first step is to simplify the addition of the fractions on the left-hand side of my equation. Recall, when adding fractions, we look for a common denominator. X and y are unknown variables. Therefore, the common denominator would be their product, xy. When adding fractions, I take the numerator of my first fraction, 4, and I multiply it by the answer I get when I divide x into xy, which is y, plus the numerator of my second fraction, 3, and I'm multiplying this when I divide y into xy, which is x, and that is equal to 7 over t. Simplifying this, 4y plus 3x all over xy is equal to 7 on t. T is in the denominator on the right hand side of my equation. I need to remove t from my denominator. So I need to use the opposite operation to division, which is multiplication. And whatever I do on the right hand side of my equation, I must do on the left hand side of my equation. So I get t over 1 times 4y plus 3x over xy is equal to 7 over t times t over 1. On the left hand side of my equation, when I'm multiplying fractions, it's simply as multiplying the numerators and multiplying the denominators. So I get t times 4y plus 3x divided by 1 times xy, that is xy, and that is equal to, on the right hand side of my equation, I notice I have t in my numerator and t in my denominator. The two of them will divide into each other, and that is equal to 7. My t term is being divided by xy. I need to remove xy from the left hand side of my equation, so I need to use the opposite operation to division, which is multiplication. So I get t times 4y plus 3x divided by xy times xy over 1 is equal to 7 times xy. Since I multiply xy on my left hand side, I must multiply xy on my right hand side. On the left hand side of my equation, I notice I have xy in my numerator and xy in my denominator. So the two of them will divide into each other. Xy into xy is 1, xy into xy, that is equal to 1. So I'm therefore left with t times 4y plus 3x is equal to 7xy. I want t to be the subject of my formula. And right now, t is being multiplied by 4y plus 3x. I need to remove 4y plus 3x. So I need to use the opposite operation to multiplication, which is division. So t times 4y plus 3x divided by 4y plus 3x is equal to 7xy divided by 4y plus 3x. On the left hand side of my equation, I have 4y plus 3x in my numerator and my denominator. The two of them will divide into each other. Therefore, t is equal to 7xy all over 4y plus 3x. And that is my answer.